Hi everyone, it's Mr. Banish, and in this podcast we're going to take a look at winds. To start with, we need to give wind a definition, and we talked about that in class. It's the horizontal movement of air from an area of high pressure to an area of low pressure. And we saw that when we were working with the cans and we got the cans to basically flatten out. We were talking about pressure and how we had the molecules that were spread apart and they moved to an area where there was lower pressure, and the two combined and it actually caused the can to basically collapse. And so I have an example of one of those right here. So you can see that the can is not how it originally was, and that was something that was important for us to understand because it showed us pressure, and pressure is a major component for wind. Wind is caused by the different air pressures, and another example that you can see is from these pictures. You can see that there is a plastic water bottle. And at normal pressure, the air that's on the inside is going to push or expand on the bottle. And if you go to different pressures, it can have an effect on the bottle. In this case, it's causing the bottle to squeeze down a little bit. And if you look at this picture, it's squeezing even more. So just by changing the air pressure, you can actually change the properties or the way that the water bottle looks, just like we did with the can in class. We measure winds by different speed and direction, and there are two instruments that we use. The first one is the instrument that is over here. That one is called a wind vane, and what it does is it measures the different directions that the wind blows. So it could be a wind that's blowing from the north or the south or the west or the east, or maybe the northwest or the northeast or the southwest or the southeast. And what happens is that as the wind blows, this turns in the way that the wind is blowing. So we're able to look up and say, oh, it's a west wind today. Over here we have what is known as an anemometer. And what that is that's an instrument that's used to measure wind speed. And so what happens is that these cup-shaped things get wind that blow them, and as they begin to turn, they slowly start to go faster and faster, and what it does is it records the speed that they are moving at. So two different ways that we measure wind. It is both in direction and in speed. The wind chill factor is another important part of wind, and you hear that a lot talked about in the weather when it is winter time. And the reason for it is it's the measuring of cooling, combining temperatures and wind speed together. Basically, it's how the wind and cold of the temperatures feel to your skin. And we have this a lot of times when we're trying to figure out whether or not we should close school. We want to make sure that it's safe for everyone to be able to be, if you have to walk to school or if you have to stand outside at a bus stop waiting to get picked up. And so what meteorologists do is they have a chart that looks similar to this. And you can see that you have temperature, and over here you have wind. And what they do is they just see where the two cross each other. So if it's 5 degrees outside and it's a 25-mile-an-hour wind, they cross over at about -17 degrees. So it would be, even though the temperature outside is 5 degrees, with a 25-mile-an-hour wind, it's going to put it and make it feel like it's -17 degrees outside. So a lot of times you'll hear meteorologists, if you're watching the weather, they'll say, you know, it feels, or the actual temperature outside is 5 degrees, but it actually feels like -17. When they say that it actually feels like, what they're referring to is the wind chill factor. So that one's important to understand because it obviously has an effect on us living in Wisconsin. Another area of winds are the local winds, and basically these are winds that blow over shorter distances. And local winds are caused by unequal heating of Earth's surface within a small area. And earlier this year we did a lab that had sand and water, and so in this case we have land and water. So same idea, we have a solid and we have a liquid. And during the summertime, what happens is that as the sun beats down onto this land, it is going to heat up very, very fast. And the warm air is going to begin to rise. And as it does that, the cooler, more dense air is going to move itself in underneath, and so a lot of times you'll see that even on really hot days, it's actually going to be cooler near a lake or a ocean or some very large body of water, and it's due to this heating of the land and most of it rising up because it's less dense, and then the cooler, more dense, cooler air moves in and overtakes it, and as it does that, we actually feel cooler temperatures near the lake. And Milwaukee is a prime example of this. A lot of times if you go to the lake shore, you'll see that the temperatures are sometimes a little bit cooler on hot days, and depending on which way that the wind is blowing. The exact same thing happens, except reverse, sometimes during winter. And so what happens is that now you have cooler air that is going to be coming from the land, and so obviously you have colder temperatures, and the lake actually has warmer air that is going to rise, and it helps to kind of circulate this and keep temperatures at a more comfortable temperature. And so this one is good too. And so our definitions, we have a sea breeze and a land breeze. A sea breeze or a lake breeze is a local wind that blows from an ocean or a lake, which is unequal heating often occurring along the shores of a large body of water. Land heats up and warm air rises. Cooler air then moves underneath. And for a land breeze, it's the flow of air from land to a body of water. The land cools more quickly than the water, so the air over the land becomes cooler than the air over the water. And warm air over the water expands and rises, and cooler air from the land moves beneath it. And so these do a nice job of heating and cooling, especially during summer and winter, along major bodies of water. And so we're talking about oceans, and we're talking about Great Lakes. So those are local winds. And there's also another type of wind. It's called global winds. And global winds are the steady blowing of winds over long distances. And what happens is that our whole Earth, as we know, is turning, and so we end up having global convection currents where there's more direct sunlight that is occurring near the equator, and it warms up so that the air rises, and cooler, heavier air near the poles sinks down. And it's this idea of the heating and cooling that we had talked about, except now what we have going on is, I'm going to try to draw it for you here. Going to grab our pen. So if this is our Earth, and if the Earth is turning, we know that the sun is going to be giving direct sunlight towards the equator. So the equator gets the warmest temperatures. So that air begins to rise up, and so we start to see that it's less dense, so it rises up. The air that is near the poles comes sweeping down and actually starts the circulating. So we see this rising, cooling, falling, rising, cooling, falling, and we call those same term as convection currents, but now we just attach the keyword of global. Okay, so global convection currents is a major importance to understand. And the Coriolis effect should be a reminder that it's the Earth's rotation that makes wind curve. If Earth did not rotate, wind would not blow. It would blow in a straight line from the poles to the equator, but due to the rotation, they are turned at an angle. The definitions of the global winds, there are trade winds, polar easterlies, and prevailing westerlies. There's also a term that's called the doldrums. The doldrums are found near the equator. They have very little wind. The trade winds are when cold air over the horse latitude sinks. It produces high pressure and causes surface winds to blow towards the equator. Horse latitudes, when the warm air that rises towards the equator flows both north and south. The prevailing westerlies are winds that blow towards the poles. These play an important part in the weather of the United States, and the polar easterlies, which are cold air near the poles, sink and flow back towards lower latitudes. The mixing of warm and cold air along the polar fronts has a major effect on the weather in the United States. So those are a lot of definitions, so let's take a look at what it actually looks like. This is what our global winds look like. So again, you can see that we have our equator that is located right here. And what happens is, again, the Earth is turning. And so we have our, just like we saw in the lab, we have our winds that are blowing this way. And we refer to these as the trade winds. Right in there. And this area, because of the fact that there is really no cooling that is occurring in that area, we refer to that as the doldrums. And the doldrums have very, very warm temperatures, which we would expect near the equator, and it ends up having hardly any wind that blows there. This area right in here is another area that has both warm and cool, but we call that the horse latitudes. And this area up in here is the polar westerlies. This has warmer temperatures than the poles, so we call these the prevailing westerlies, sorry, prevailing westerlies. And our polar easterlies are found up here. So polar easterlies are found in this region. And what happens is that we see convection currents again. This area is warmer, so it rises. The cooler temperatures swoop underneath, and so they get heated, they get shifted back towards the North Pole. They get cooled, they come flowing down, the warm air rises, and so we start to see this circular pattern that begins to occur. Same thing happens here. The cooler air begins to move towards the equator, it gets heated, and it keeps falling in the circular pattern. And so we start to see these uneven amounts of air pressure. Same thing down here, these are the trade winds. I'll just say trade. And this is the horse latitudes right in this region, another area that has both warm and cold and not a lot of wind that occurs there. And then this region right here is your prevailing westerlies, and the polar easterlies are found down here. And again, you start to see this cool, warming, heating, rising, cooling, falling, warming, and it just keeps going in the circular pattern. Same thing here. We start to see that we have convection currents, but we call them global convection currents. So understand that the Earth is always heating, cooling, and falling back down in terms of air movement, which causes our global winds. And then finally, the jet stream. About 100 kilometers above Earth's surface are bands of high-speed winds, and in the image you can see that there's basically different jet streams that move. You have ones that are subtropical and polar, and sometimes those will move into different areas, and the subtropical ones oftentimes brings warmer temperatures, and it brings along with it moisture, and we get storms out of it. But there's also a polar jet stream which can move into our area, which can bring with it a lot of cool temperatures or cold temperatures, and these are constantly flowing, and so we start to see that there is a lot of air movement that occurs in the world. And so winds, they play a major role, and I hope this was helpful.